Homework Hotline, what is your emergency?
Hello and welcome to the Homework Hotline. My name is Nathan. Here at the Homework Hotline, we can help you with your most challenging homework questions, and I'm here to help you with math.
And hi, I'm Sam. I'm here to help you with your science questions.
Hi, I'm Becca. I'm also here to help you with math.
So we're here every Tuesday and Wednesday from 4:30 to 5:30. Give us a call at the number on your screen, 720-424-1666. It's really helpful when you call in because we can help you work through the problems piece by piece.
You can watch our show in several different ways. For broadcast, you can watch us on Comcast Channel 22 or go to livestream.com and search for EG Homework Hotline. If you would like to see some of our past shows, watch us on YouTube by searching for DPS TV Homework Hotline.
The Homework Hotline is sponsored by Contemporary Learning Academy and Emily Griffith High School. Lily, an EGHS student, will be leading us in trivia questions. Lily, you want to tell us a little bit about yourself and then go into the question for today?
Hi guys, I'm Lily and I'm a senior at EGHS this year. The Homework Hotline loves to be accommodating to those of you who like to turn in your questions on social media, and I help get those questions over to our teachers. And I am also the trivia queen, so at the top of each show I will ask you, the audience, a trivia question, and before the end of the show I want to hear the correct answer from you guys. And if you call in with the correct answer, you will get a prize. The trivia question can be on any subject, but today we have a history question. So today's trivia question is, what was the world's first combustible engine automobile? And we will answer that at the end of the show.
So if you have an answer to the trivia question or a question to ask us, you can give us a call at the number that was given to you earlier. It's on the top right of your screen, 720-424-1666. Or we also have some other ways that you can get a hold of us if you'd like. Even though we prefer talking to you on the phone, you can definitely hit us up in social media, so Facebook or Twitter at EG Homework. You could text us at 970-680-3771, or you could also email us at homework@emilygriffith.edu. So if you've got some questions for homework, those are all of the different ways that you can get in contact with us today until 5:30 to get those questions answered. So Lily mentioned social media. So we have some questions that have maybe piled up overnight or over the weekend. So let's go get some of those answered.
So we have a science question first, and this asks, in a certain species of plants, the color purple is dominant to the color white. One parent is dominant color purple. The other parent has different alleles, if I pronounce that correctly. Mm-hmm. According to the Punnett Square, what is the probability of an offspring being purple?
Cool, yeah, science question. I don't usually get to go first. I'm very excited.
I like Punnett Squares though.
I do too. Well, it's a mathy science thing, right? So Punnett Squares are a way that we predict probability of a particular genetic trait. So this is such a common question. There's actually, let me pull up a picture here. There's actually going to be, great pictures online. So if you go to my screen, possibly. So this is an example of the exact question that's being asked, and this is a really common example given in biology classrooms. So the question is, if you have two parents, and let's see, the color purple is dominant. One parent is dominant color purple. The other parent has different alleles. Okay, so this is not exactly the same, but this is an example of two plants like that. So in the example I have on the screen, I've got two parents, and the parents are represented by the gray peas. So up on top I have, let's say this is the papa flower, has dominant pea, and then the little pea represents recessive pea. And then we'll say over here on the side, these two peas are mother, so dominant pea and recessive pea. So in our example though, this is slightly different. So maybe, Nate, could I possibly get you to help me with a drawing here?
Sure.
Awesome.
I'm so good at drawing.
You are the drawing champion.
He really is.
So that is, I mean, your stick figures are unmatched.
Thank you.
So this is going to be slightly different. So in the Punnett Square that Nate's going to draw for us, we're going to have one parent that has two dominant alleles, and then we're going to have another parent that has one dominant and one recessive. All right, so above the square, could you write a capital P, capital P?
Capital P and capital P.
Right, so this is going to be the parent that has two dominant alleles, and this flower is going to be purple. The dominant color when you have one or two alleles that are purple, you're going to be a purple flower. That are the dominant, you're going to be a purple flower. And then on the side, let's do big P, little p. Okay, perfect. That's nice and little. I love that.
It's like, well, big P's and little P's look the same.
Like,
really.
we could use
similar, right?
kinda-
Cursive,
Right.
sometimes you'll see
Ah, that's
cursive
true.
as like a way to distinguish the two.
Yeah, I'll do
but
No,
that.
this is
Cursive.
so
I like
perfect.
There you
it.
go.
I like
We
it.
can tell which one's recessive. Okay, so the deal is going to be, the rule is going to be that each parent is going to contribute half of their genetic code to their potential offspring, and there's 4 potential offspring being represented here. And if we end up with a parent that is dominant, as in 2 big P's, we're going to have a purple flower.
Okay.
And if we have a parent that is dominant recessive, so big P, little p, also going to be purple. The only example of a white flower would be if we had little p, little p. So let's see if we end up with any white flowers in this example. So in the top left box, we're going to put big P, that comes from those 2 parents right there. So big P, that's going to be a purple flower, 2 dominant purple traits. In the top right box, let's put big P again. Same exact thing. In the bottom left, we're going to put little p, big P. And let's just do the one on the bottom right. Well, it's the same. It's going to be little p, big P. Perfect. Okay, so what we ended up with is 2 potential offspring that are going to have the dominant allele, and 2 potential offspring that's going to have 1 dominant, 1 recessive. However, in this example, with this particular kind of a genetic trait, even if you have the recessive gene, as long as you have 1 example of the dominant gene, you're going to end up purple. So in this case, the answer to the question would be all offspring, 100% of the offspring of these 2 plants would end up purple.
Just means that half of them can have white,
Could potentially have
Offspring.
white offspring. That's a really good
but
point.
only half of them can have
Oh,
white,
okay.
white offspring.
That's exactly
Because
right.
they can then spread their little p, to another.
Right.
They would just have to have somebody else
Exactly.
with another little.
With another little p, right? So if one parent was dominant recessive and the other parent was dominant recessive, you would have a 25% chance of having a child that was recessive. In other words, a white flower in this
I
case.
love those.
Yeah, they're kind of fun.
They look a lot like the area model, and they work a lot like the area
Yes,
model that we use
yes.
in math. And it's probably the one time I really get kids saying, "Oh, I've seen this in my science class."
Right.
You see the connection a lot, and you're like, "Well, there's a lot more than that." But
But it's an obvious connection.
okay, well, great question. Let's go get a couple more questions answered from Lily.
This one asks, is 25,897 minus -6 positive or negative? And what is the answer?
Do you want to do it?
I guess I can take that one. We could. I don't know. Would you use a number line to explain this?
I think the way I was thinking about it was thinking of the negative sign as like a signal for opposite. So opposite.
Right. So I guess kind of what I was thinking is if you think of a number line.
Like left and then right, like
Yeah.
changing direction.
So if we start here at, is it really unnecessarily big numbers? 25,897. So that's clearly a positive number. And we're going negative direction, basically. So like Becca mentioned, it's kind of like the opposite, and it kind of, I don't know,
Right.
undoes itself in a sense. So if we were subtracting 6, this would be the negative direction. Right, this is a negative direction on number line. But we're subtracting a -6. So you could think of it as like, well, we're going this way, but then we're subtracting, so we're going back this way. So this is why 2 negatives make a positive. So actually what we're doing is going this opposite direction, and we're actually adding 6. So, I mean, just based on the size of the number and how much bigger 25,000 is than 6, it's definitely going to be positive. But because we're subtracting a negative number, we're kind of doing the opposite and adding it. So we would be adding 6, and we would be at 25,905.
I know.
So
you might be able to explain that a little bit more in detail.
It's just that there are a lot of ways to think about integer addition and
Yeah.
subtraction. You could think of a negative number as owing money, and as subtraction as I guess,
Owing more money?
yeah, or I guess maybe you could think of it as like giving an IOU, like or maybe another way to think of it would be, what was I thinking? Oh, in English, like when you have double negatives.
Oh yeah, can't not
Right,
would mean that you can.
right,
So negative negative would mean positive. Right.
right. So with integers and integer addition and subtraction and multiplication division, there are a lot of different ways you can think about it. Sometimes we use the number line model.
Right.
Sometimes we use the number chip model. So like black and white chips, black chips being negative and white chips being positive, and black and white chips cancel each other out. It's another way to think about it. But I mean, that's the thing with integers is there are a lot of ways to think about it, and it
Right.
tends to be one way that makes sense with one person, whereas another way makes sense
Yeah.
to another person. But I liked your way with the number line. Minus means going to the left, but if you see two of them, you're going to switch the direction.
Right. So we're going a negative direction, but we're going negative that, so we're going back in the positive direction.
Exactly. Yep. All right. Well, let's get some more questions answered. Are you ready, Lily, for
Yeah.
another question?
So we have a sides one and asks, what is the mass of 2 mole of H2SO4?
Oh, sweet. Nate, I'm going to ask you to help me out again with this.
All right.
2 moles.
Sorry to be a pain.
Okay.
Okay,
What am I
so
doing?
cool. So Nate, would you write just the chemical formula on your screen, H2SO4, and the 2 and 4 are subscript?
Right.
So
You
this is-
know, I
go
want to
ahead.
say something before you start.
Please.
I think now that I've been here for Homework Hotline, I think I could almost do that.
Nice, that's awesome to
Now
hear.
that I've been here for Homework Hotline.
That's awesome to hear.
But anyway.
So one thing
Just
you
a
would
little
need
brag.
is you would need
Just
to know
brag
the
to-
weight.
No, it was a brag on you because you're explaining it so well that I understand it now.
That's awesome. Cool. Well, I just to return the favor, my math has definitely improved at getting some of the,
Good.
the
That's our
basic,
goal. That's our goal.
reteaching here.
So guys, watch the Homework Hotline.
That's right. That's right. It's working for the people on it. So,
Mm-hmm.
so H2SO4 is sulfuric acid, and what we want to do, the first thing we need to do is figure out what is the mass of 1 mole of sulfuric acid. And just to tangent for a second, because I think it's an important tangent. Before you answer this question, you might want to know what a mole is. And the word mole in chemistry is a word that represents a number, much like we might say a dozen is a word that represents the number 12. The word mole represents the number 6.02 times 10 to the 23rd power, which is a gigantic number. It's effectively 6 sextillion, which is it's a number so big it's hard to even think about. But a mole refers to a quantity of some material where you have that giant number, 6 sextillion pieces of that substance, whatever it is. So for example, if we had a mole of oxygen, we would have 6.02 times 10 to the 23rd pieces of oxygen molecules. Or if we had a mole of sugar, we would have 6.02 times 10 to the 23rd sugar molecules. And sugar weighs a different amount than oxygen, so moles of different things have different weights, but a mole is always that same number, 6.02 times 10 to the 23rd. So, little tangent. If you use the periodic table has weights below each chemical symbol, and those weights are, sometimes we say that it's the atomic mass unit weight, but it's also really useful because it is the weight in grams of 1 mole of that element. So below the letter H on the periodic table, there is a 1.00, which tells us that 1 mole of H weighs 1.00 grams. So the way I would set this up, Nate, is I would basically say, okay, I've got 3 chemicals here. I've got H hydrogen, S sulfur, and O oxygen. So I'm going to do 3 little operations and add them together. So the first is going to be in parentheses, so starting parentheses. I'm going to put 2 times, and this is because I have 2 H's, and then 2 times the weight of H. And in this case, the weight of H is just 1. In all cases, the weight of H is 1. Fantastic. So let's close the parentheses, and let's add that to the next chemical. So the next chemical we have is sulfur, and because I've been doing a lot of chemistry lately, I remember that the weight of sulfur is 32.06 grams, and we don't need to put a multiplier because there's no subscript next to S, meaning there's only 1 sulfur atom in a single molecule of sulfuric acid. So we're going to add, and this time we have 4 oxygen, so let's put the 4 multiplier, and the weight of oxygen is 15.99 grams per mole. and Becca's going to help us out with a little calculation there. But this is how you would set these problems up, is you would essentially break it into, you'd have 3 sets of parentheses for each of, or a set of parentheses for each chemical. You multiply the weight of the single chemical by the number, and you get an answer. In this case, we would get 98.02 grams. And this is grams per mole, remember. So this is 1 mole of sulfuric acid, right? 6.02 times 10 to the 23rd molecules of sulfuric acid weighs 98.02 grams. The question asked us, how much does 2 moles weigh? So we're not quite done yet. We have to do just one more thing, which is we need to multiply our answer by 2. And we would get 196.04 grams in 2 moles of sulfuric acid. Does that make sense?
Mm-hmm.
Yeah.
That's what I was going to do.
Oh, see, I should have just
Really,
let you do
I
it.
was.
I could have fed you the weights, and I should have just let you do it.
Actually, what I was going to do.
I'm interestingly struggling a lot in class right now to get students to see those 2 steps. They're really good at calculating molar mass, and then separately, they're really good at multiplying molar mass by the number of moles they have. But sometimes if a question asks for both things, they miss that there's 2 steps there.
That's interesting.
It is.
That is really interesting. Well, we're going to take a little break from answering questions, and we are going to check out a real-world apps from one of our teachers from last year who answered language arts questions. Her name is Whitney McCabe, and she was, I'll have you check it out, but she was looking at how language arts can be used in the real world. So check it out.
I'm Whitney McCabe here at Hangar 30, a marketing agency for Real World Apps Language Arts. All right, Ryan, tell me about yourself, your name, your position, what do you do here?
Sure. My name is Ryan Woodhouse. I am a content and product specialist for Hangar 30. We are a digital marketing agency, or content producers, if you will, for primarily clients within the Department of Defense. So we service a lot of clients within, like programs within the Air Force or the Air National Guard, for example.
So what is a content and product specialist?
Primarily, I write a lot of content, everything from long-form blog posts all the way down to 140 characters in a tweet on behalf of our clients and our individual programs. As far as the product specialist part, I typically will be in charge of coming up with enhancements to our programs and pitching our clients on either new products or ways we could change products on their behalf to make them more effective and things like that.
Tell me about your day. When does it start? What do you do? What's the process?
I get in around 7, which is way too early, but that's when I start my day. Then I typically work into my day. I can't just immediately start and hit the ground running. That's why I do, say, brain exercises, or I'll watch a TED Talk when I first get into the office, and then I'll start with something that comes most natural to me. One of my duties around here is I'm the resident social media expert. So I'm actually in charge of and run several of our social media campaigns for our different products.
So how long have you been a content and product specialist?
I've spent the last 5 years in digital marketing, but I've actually only been here for about 3 months.
What was your undergrad degree?
I did journalism and mass communication with a strategic communication focus at the University of Wisconsin. Go Badgers.
So were you always attracted to this type of work?
I was pretty convinced that I was going to do something in medicine. And then in high school, I got a job working for the local NBC station in my hometown, and actually ended up working as a reporter for the teen magazine show.
Did you always want to write, or have you always enjoyed writing?
I always enjoyed talking more than I did writing. And that's kind of how I think my writing style developed. I've always been more conversational in my writing, as opposed to, say, technical writing, where you have to reference a lot of facts and figures and be very, very strict with your speech and your word choice.
So how important was what you learned in your English classes in high school and college to what you do today?
It is definitely important. A lot more than I would have thought is in working with people and client relations and finding out exactly what it is that your clients are after. And obviously a lot of the basic concepts and things that I've learned through language arts classes in both college and in high school are directly applicable. I mean, you can have the best idea in the world, and if you can't accurately describe it to someone, then it's pointless. Then you don't have, then you may as well not even have an idea.
What do you think students that maybe want to go into this field while they're in high school, what should they be focusing on?
I think my number one piece of advice would be to practice brevity. That's been a big thing, especially since we've transitioned more into social media marketing. So being able to use as few words as possible. Word choice is key, and learning to be as brief and as concise with your word choice and your writing and your work.
What would you recommend to a student that's facing writer's block?
The first thing I do is take a step back. It's almost like if you have a problem with an app on your smartphone, turn it off, turn it back on. Take a step back, take a breath, go do something else for 10 minutes, and then come back, and all of a sudden, a lot of times for me, something will spark.
When you're writing a story for an ad campaign, do you write a story? Do you write a script? How do you start, and then what does it become?
It starts with knowing the expectations of the client. Finding out exactly what it is they're looking for is item number one, and then we find the best way to attack that problem.
How closely do you stick to the rules of grammar and English when you're writing copy?
It does depend a lot based on the medium that you're using. If this is a social media campaign, obviously it's going to be much more conversational. You're not going to follow as many rules. You still have to follow a lot of punctuation and grammar rules just to get the point across and make it easily understandable.
Has texting affected your industry?
I don't think texting has changed enough of our understanding of the English language that we have to write specifically for texting, but you do have to take it into account. You have to be mindful of the way somebody who is texting and having a conversation solely on their phone without actually speaking to another person or reading a long-form sentence, how they're going to read and interpret a statement.
What other school subjects do you use in your profession that might surprise us?
I do a surprising amount of math. In creating campaigns, and a lot of different tools that we create for our apps deal with financial calculators and things like that. So a lot of math goes into creating that content.
So, are you a grammar nerd? Would you call yourself a grammar nerd?
Yes. It has made Facebook almost unbearable.
Yeah, I agree.
Not having proper grammar and punctuation, it drives me nuts, seeing that day in and day out.
What do you think of Weird Al's word crimes video?
That is my jam.
Do you have a favorite punctuation mark?
Oh, the exclamation point.
Oh, really?
Uh-huh.
Mine's a semicolon.
Absolutely. Why?
Just Wonder
What do you
Woman.
do with the semicolon?
She can work on her own. She
I
doesn't need a
suppose.
conjunction.
Fair
She doesn't need a
enough.
capital letter.
Fair enough.
Oh,
But if you
yeah.
flip it upside down, it doesn't mean the same thing in a different language.
So thank you so much for spending your time with us today. We know that all of our watchers are going to appreciate this real-world application of language arts.
Thank you so much for having me.
Thank
I
you.
appreciate it.
Hi, welcome back. Hopefully you enjoyed the real world apps. We like to do those every now and then just to give you an idea of where the subjects that you're learning about in high school will actually be used someday in your lives. So let's go back to Lily and get some more questions answered.
So right here we have a math question and it asks to solve for x. And here's the equation. It is too long for me to state, so
It is
yeah,
quite
there
long.
you go.
So I during the break, I went ahead and copied this onto my screen so that you guys wouldn't have to sit here and watch while Lily read it to me. But here is the equation. Is rather long, but we're going to try and make it a little bit easier to solve. So one of the things that I notice here appears a lot of times is the distributive property. And typically if you see this in an equation, and I'll show you what that is in a second, that's what you really want to take care of first, because when we have numbers written this way, we can't combine any like terms, we can't make anything simpler, and when you have a long equation like this, especially, you want to try to make it as simple as you can. So distributive property is this. This is an example of something where you would want to use the distributive property. And what we need to do is that we're saying that this is 4 times the quantity, because of the parentheses, of 5x plus 17. So we would need to make sure that this 4 gets multiplied by the 5x and also by the 17. So we'll take 4 times 5x, we get 20x. Then we'll do 4 times 17, we get 68. So that's the first one, and we'll do a similar thing to the rest of them. So plus 7 times 21x, so 7 times 21x is going to give me 147x. And then we also need to do 7 times, and this time we'll think of this as -5, so minus 35. And then again, we'll continue. So 3 times x, 3x, 3 times 4, 12. And then keep continuing, plus 9 times x, so plus 9x. And then 9 times -3, -27. Still quite a long equation. So we really haven't made things simpler, but we have kind of opened it up to where now we can start combining like terms, putting things together that are similar. So like terms would be, for example, this, 20x and positive 147x. 68 would not be a like term with 20x because 20x is saying 20x's, 68, it's not the same. There are no x's there. So when we combine like terms, we also want to make sure that we only do it on either side of the equation. We don't want to combine them all that are the same. That equal sign keeps things separate for us. So I will, on the left side, I'll combine the 20x and the 147x. And then on the right side, I'm going to combine the 3x and the plus 9x. And we do always consider the signs with that. So 20x plus 147x is going to give me 167x. And then on the right side, I have 3x plus 9x. That gives me 12x. So those are the x's. Then we're going to have to combine the other terms, which are constants. So we have positive 68 and negative 35, which is going to give us positive 33, so plus 33. And then on the right side of the equation, we have positive 12, negative 27. And that's going to, when we put those two together, and when I say put them together, just add them together, and you'll end up getting negative 15 there. And now, as you can see, we have a much simpler equation. One thing that tends to throw people off is the fact that we have variables on both sides of the equation. That really does tend to throw people off. So if that's something that confuses you, you're not alone. And it is kind of a problem, and the way that we can solve it is just by getting our variables all on the other side of the equation. Now the side doesn't really matter, that what we do it on. I tend to put all the x's on the side that has more of them already. So I'm going to take this 12x, I want to move it to the left side of the equation. In order to move it, I have to do the opposite of what is there, which means subtracting it. So I'm going to subtract 12x from both sides of my equation. What happens on the right is 12x minus 12x, that gives us 0. So we're just left with negative 15. And on the left, we now have 179x plus 33. Starting to get simpler. We need to find out what our x's are, so we're going to undo all of the things that are going on with this x. We have 179 times x, and we have plus 33. We'll start with this and subtract 33 from both sides. And that's going to give us negative 48. Am I off on my numbers? Oh, I was supposed to subtract.
Yeah,
sorry.
Yeah.
Guys, you gotta keep me on this.
We were gonna do it. You were just on a roll.
Keep you honest.
Okay. So I was supposed to subtract my x's. Sorry, it was 155x. I added the 12. You're supposed to subtract. So we have 155x is equal to negative 48. Now, what we want to think of is that this is connected with multiplication, and so to undo multiplication, we're going to divide. Basically doing inverse operations. So in this case, and I'm going to use a calculator because it's going to be a decimal. And we end up getting not a very nice decimal, but that's okay. It's negative 0.3096, but then the next number is 7, so we're going to round it to this. And if I were Nate, I would go back and I would plug in my solution for x. I would plug it in and replace it in my equation to make sure it works.
Yeah, you should go ahead and do that.
But since this is such a long equation, would you like to do it for me?
No, I think you already
I know
started
you
this
love
one, so.
checking, so I could let you do it if you really like.
I think, well, it's gone now.
Oh,
Too late.
missed our opportunity. But we could replace our x with our solution and check to make sure both sides were equal.
These problems are interesting because I feel like they're very intimidating to a lot of students.
Mm-hmm.
But the process, no matter how big or small the problem is, like the process is really the same of like simplifying and combining like terms.
Mm-hmm.
And then
What
looking
would you say
for a way
if you were to
isolate.
generalize that process? Like, you would say distributive property first.
Sometimes I've said distributive if necessary, but I think if you said simplifying, that might be a more inclusive term because that would include distributing, right?
True.
But yeah, that's what I do. Distribute, combine my like terms, make sure your variables are all on one side,
Variables on one
and
side.
then inverse operations to isolate. That's typically how I teach it in the sense of like,
Oops, that's another
here's
lead.
4 steps. If you're not sure what to do, apply this step. Think about how you can apply this.
Operations. And inverse operations meaning if there's addition happening to your x, you're
Right.
going to subtract. If there's multiplication, you're going to divide, and so on.
Mm-hmm.
So this kind of, I guess, generalizes the whole process that we just did. And that is the thing that's so confusing sometimes, is that every different equation that students get, they're like, well, I did know how to solve the last one, but now I don't know how to do this
Right.
one because it looks different.
Right, and the process is still the same. It's just
Right,
a little bit different manipulating.
depending on what you're presented with.
Yeah. Well, it sounds like I think we have a caller right now, actually. Is
Oh, okay.
that right?
Hello?
Hello?
Caller, are you there?
Can you hear me? Hello?
We might have lost our caller.
Yeah.
Hello?
So,
They can't hear me. I'm on.
Okay, well, if you still have your question,
Hello,
just give us a call
hello.
back. We'll try to connect
Can
with
you
you
hear
again
me?
in just a second.
Hello?
should we hop back over to Lily then?
Yeah, in the meantime, I guess let's get some
Yeah,
homework
I am
questions
going to
answered.
pull up a quick science question. Here you go. All right.
Sweet.
Cool. And if no, all right, well,
Oh, it's okay. I saw what it was.
all right, yep,
I
we
just
got
say
the
it?
point, yeah.
Okay, so
You got the
the
point.
question that I read was, how is a biome identified? So a biome in biology or ecology is just going to be a physical space that's occupied by a particular type of groups of types of plants and animals. So a biome is defined by the precipitation and the temperature of the region. So you might have, for example, a rainforest, which is going to be an area with high precipitation. And you could have a colder kind of rainforest, like the kinds of things you would get in the Northwest, like a deciduous rainforest. And you could have a tropical rainforest, and those differences are going to be distinct based on the temperature. And then you could have, a desert, which would be low precipitation, and you can have warm deserts like you get in the Sahara, and you can have very cold deserts like you get in the Antarctic. So really the big difference is temperature and precipitation. And
I actually threw up a picture there if you want to show that.
Oh, sweet.
Of the main biomes in the world, like you mentioned.
cool, please, let's
polar.
take a look at Nate's computer here if we could.
Really interesting.
Yeah.
So, perfect, Nate. I was literally just going to look for this picture. So this is excellent, right? So you see plotted along the x-axis, you've got the annual temperature, and you've got the annual precipitation plotted along the y-axis, and the different biomes that exist depending on what the relationship is between the temps and pressures. So you can see way down there, low temperature, precipitation. Low temp, low precipitation, that's going to be tundra, like the Arctic. High temperature, high precipitation, way on the other end, on the top right of the graph, is going to be a tropical rainforest, and then everything else in between. Thanks for that, Nate.
Mm-hmm.
Awesome, really interesting.
Mm-hmm.
Well, we haven't fixed our issue with our call yet, so call us back. But in the meantime, we're going to take a break and take a look at some words from some of our sponsors. Lily.
There's times when you wander and ponder all the labels you've received.
Believe me, I've got a few. Never mind from when, why, or how.
'Cause now, everything's different. I found the perfect place.
A space where the labels fade and I'm accepted and supported.
Check what the news reported. Emily Griffith helps all who wish to learn.
Turn towards your future while you finish the basics on your time.
Prime opportunity in this mature environment.
The only requirement is motivation and thirst for success.
Invest in your passions. There's no limit to how far you'll go.
And know that you'll have something in common with everyone here.
We all chose empowerment over standing still in fear.
Emily Griffith Technical College is turning 100 years old, and we want you to join in the fun. The Emily Griffith Foundation is presenting a year-long community celebration, opening doors of opportunity for 100 years. Here's how you can play a part.
Are you 1 in 2 million? Shop Automotive has donated a 3-year lease on a Mini Cooper that one lucky alum of Emily Griffith Technical College will win. All you have to do is sign up.
Go to egfoundation.org for more information.
Welcome to Nerd Necessities Network. You're probably thinking, what is Nerd Necessities Network? That's a good question. Nerd Necessities Network is a premier DPS TV show all about nerdy people, places, and things. Check us out on Facebook and YouTube and all the social networks. That's a wrap!
Welcome back. I believe we got our caller working.
Oh, good.
So let's try that
Hello?
again. Oh, hello.
Hello? Hi.
Hi.
Is this the homework hotline?
Yes, it's the homework hotline. Did you try calling earlier?
Yeah.
I'm glad we got
so glad
you.
to be through.
Well, I'm glad we got you. What's your question? How can we help you?
My question is, what is the difference between mitosis and meiosis?
Oh.
Right on. Okay, so that's
Good
going to be
question.
science. That's me. Meiosis is fine.
Who
We
am I
usually
speaking with?
say meiosis.
He wants
but,
to know who he's talking to.
I'll take meiosis. Oh, you're talking to Sam, the science teacher from CLA?
Oh, okay. Hi, Sam. And it's meiosis?
Meiosis, that's right.
Meiosis. Okay.
Cool. Okay, so the first thing to understand is that mitosis and meiosis in general, these are two different processes that animal bodies use to make new cells. Does that sound okay so far?
Sounds fine, yeah.
Okay. Awesome. Okay, so for example, on your body right now, your skin cells are growing all the time, right?
Ooh, okay.
So yeah, kind of an interesting / maybe gross thing to think about because we actually have lots of dead skin cells coming off all the time. But the first one that you talked about, mitosis is simple cell division for growth. So if an animal is getting bigger and needs to make more cells, it's going to use mitosis to make more of the same kind of cells that it already has. Does that sound okay so far?
Yeah.
All right. So let me pull up. I've got a picture on my screen. Are you watching the show right now?
I sure am.
Okay, so if we
Avid
can switch
watcher.
to my screen now. It's not a perfect picture here, but this sort of breaks down the differences, the process differences between mitosis and meiosis. And if you look on the left side of my picture, I've got an image of a cell, a single cell. We've got some stuff happening in the cell, and eventually the cell splits into two. Do you see that?
Uh-huh.
Okay, and then it's a little bit difficult to see because this keeps popping back up, but on the right side you can see we have a cell splitting into two and then splitting again into four. Do you see that?
Okay.
Okay, so that's going to be a major difference there, is in mitosis we produce 2 cells, and in meiosis we produce 4. And the reason for that is this. Meiosis is the production of sex cells, okay?
Say that again?
The meiosis is the production of sex cells.
Okay.
So in humans, we have 2 special kinds of sex cells, right? Or in animals, we have sperm sex cells, which come from males, and then we have egg sex cells, which come from females. Have you heard that before?
I sure have.
Nice. So all animals that are formed through sexual combination, which is most animals that exist, they're formed by combining the genetic codes of their mother and their father, right?
Right.
So you, for example, are a combination of 23 chromosomes that came from your mom and 23 chromosomes that came from your dad.
Okay.
And meiosis is the process that happens inside of the sexual glands of the body to produce cells that contain half of the genetic information from that animal so that they can share that half with another animal and create a baby, right? So, so in all your cells in your body, you have 46 chromosomes. And every time mitosis, mitosis is the cell growth process, every time mitosis makes a new cell, it makes a cell that's an exact copy that has 46 chromosomes, just like the rest.
Right.
But in your sex cells, in your testicles, you're producing sperm cells, and those sperm cells contain just half of your genetic information, just 23 out of the 46 chromosomes that you have.
Right.
And that's because those 23 need to be combined with 23 from another person to produce a fertile offspring. And do you have any sense of why this happens, of why we have to have sexual reproduction in animals? Have you ever heard before?
I don't really want to go down that road, so I'm going to have you give me the scientific.
Okay, so the sciencey answer, the not gross sciencey answer, is just that if we were exact copies of ourselves, if we made babies by just making exact copies of ourselves,
we'd be mutants.
We could be mutants, and if we ever had problems, right, like if there was ever, maybe if I was susceptible to a particular kind of disease and I was making perfect copies of myself, and then that disease comes along, it will wipe out me and all the copies of myself that I've made.
Right.
But using sexual recombination, animals and plants are able to combine genetic codes of two different animals to make a huge diversity of different types of this animal. And it's what leads to all the diversity that we have on Earth and the resistance to different diseases or problems that might come out of particular species.
Very interesting. So on a side note, what then are there certain animals in the animal kingdom that don't need to go through this process, or?
So there are bacteria and some other kinds of microscopic creatures that are just going to use mitosis. So they're called asexual creatures. They do not recombine with, they do not use sex to make offspring.
Gotcha.
Worms, and as I'm saying this, I'm realizing that I'm not 100% sure on this, but I know at least that worms do not mate with other worms. But I believe that's because they actually have the parts of both male and female inside just a single worm. And so they're able to do sexual combination just by themselves. So a single worm can effectively have sex with itself. But really the creatures that I think of that are not using meiosis are going to be bacteria that are just making perfect copies of themselves.
Gotcha. Well, thank you so much, Sam. This has been very, very interesting, and I'm glad to have this out of the way.
Yeah, well, thanks so much for calling in. I hope you have a great day.
You too. Bye.
Bye.
That's a common bio question.
Yeah, it's a good bio question. I feel like there was a lot of information I threw out there. Like the minute that you start to peel apart the onion of what's the difference between mitosis and meiosis, you realize, oh my gosh,
it's like,
there's a ton of
what
stuff.
is mitosis and meiosis? Right. And yeah, very interesting though. Mm-hmm. It happens everywhere, all the time.
All the time, whether or not you're using it.
Well, let's go look at our Facebook because we have some interesting stuff that we put up there. Lily, what's on our Facebook today?
So today, the video that was posted on our timeline on Facebook was, what if the Civil War were tweeted? And that was kind of an interesting little video, and basically showed how the Civil War, the steam engine and the telegraph started a revolution in news broadcasting, basically. And people wanted quick information on the war, and so the steam engine made it quicker for people to print, and the telegraph actually made it easier for people to send information. It would send within minutes. So, and also, which was not brought up actually in this video, was that propaganda was also a big I guess what they would call a Civil War news revolution that happened. And so, yeah, it was pretty interesting to watch. So, yeah.
So all different kinds of technologies that are just changing the way the world works, in a sense, and the way we receive information. And I think it's really interesting to think about, well, what if it were tweeted? Using same idea, different technology, quicker, maybe more informal. I don't know.
Yeah, I guess when you think about today, how quickly things are changing with social media. I mean, social media is a thing that we talk about so often that's changing the pace of information. thinking back to the past is kind of a cool analog to imagine, okay, what must have things been like before the telegraph, before this information was sent extremely quickly across the nation to newspapers on both coasts. Before that time and then moving into that time, it must have been such a shock. And I'd imagine, you know, I think what we're going through now with a constant 24-hour news cycle, that shift is similar, or at least you can see parallels between the two.
Yeah, no, it really is interesting. I mean, even thinking about just any information and portraying any information, we can do it relatively instantly now, and this is really what started it. Back whenever we couldn't get information instantly, imagine how difficult that was to wait to hear what's going on in the war.
By like horse
in
or
our
something.
own country.
Or
What is happening? And having no idea. So, I mean, this had to be an incredible invention because of that.
Well, it was kind of interesting because it's a combination of a couple things. Like, so Morse sketched the telegraph originally, and it was basically made of 3 parts. It was like sender, a receiver, and a code for translating the signals. And he thought that that would be something that he could distribute. And he actually worked with a guy named Alfred Vail, who helped him kind of further the idea and develop that Morse code. You know, all those beeping, like the dots and the dashes.
The whole system.
Yeah, long beep, short beep. And that was a way for them to quickly kind of just send, you know, kind of translate those beeps into letters and then send really quick messages. And so that was a pretty huge deal back then, when it probably took a long time before.
Yeah. One of the things in the video that was mentioned that was kind of cool was this idea that newspapers actually printed much more slowly, or the time it would take to set up the type was so time consuming that information could come through quickly. They would already have a story set up. So they'd print one edition of the paper, and then they get this new information. They would not change the typeset for the original story, just add another story next to it. Oh, and by the way, here's the extra information. So one example that was referenced was there was a particular, and I'm blanking on the name, but there was a particular Civil War battle that was said, oh, hey, the North won the battle, and then it turned out that that was not what had actually happened. The South had won. So one edition of the paper ran that said the North had won, and then they had to essentially run the same day a new edition saying, oh, we screwed up.
It's kind of like T-shirts of sports championships.
Yes. Oh, they make both of them, and then they sell one.
Just a case, you know.
Somebody
and
out
so
there.
as soon as the game ends, they can sell them.
Yeah. Right.
But then donate the old ones to third world countries. So I've heard that if you go to third world countries, you can see a lot of like championship shirts, and you're like, wait a minute,
they never won.
They never won back in 1972.
Yeah.
That was
somebody
but,
is silk screening so many Broncos Super Bowl T-shirts and hats right now. It's happening.
Yep.
And if they, you know,
those are going to be useful.
God forbid, do not win. Then exactly. That's right. Just stay positive.
Who knows?
Well, I think we have a caller on the line.
Oh,
Let's get our caller. Hello.
Hello?
Thanks for calling Homework Hotline. Are you there?
Yeah.
Hi.
Hi.
What's your question?
All right. So to determine the height of the flagpole at school, Jacqueline, who is 5 feet tall, notices her shadow is 6 feet long. She also notices the shadow cast by a flagpole is 30 feet long. How tall is the flagpole?
All right. These questions are always exciting because I get to draw.
I was just going to say, I'm really
excited
excited to see the stick figure. Come on.
Draw Jacqueline
Are you watching
here.
right now?
Yeah.
Yeah, you get to see this art in progress.
Great
It's kind of like Bob Ross drawing on TV.
Kind
So
of. Yeah,
there's Jacqueline.
That's the artist to make the connection too.
So, you know, we got the, what just happened there? All right. So we're saying the shadow. So if you think about, like, we have a sun over here and it's got some shadow coming down. So the sun is going to basically hit Jacqueline at a certain angle, right? And it's going to create this shadow of her over here. So you said Jacqueline is how tall?
She is 5 feet tall.
She is 5 feet tall, and the
she is
shadow.
such a great height.
Yeah.
She's, that's the perfect height, just saying.
All right, unless you need to reach anything. And the shadow is how long?
It is 6 feet long.
6 feet long, so a little bit longer than Jacqueline is tall. So if you think about like this ray of sunlight coming down here and hitting Jacqueline, basically the sun is being blocked. But what you kind of see here is we have a triangle, right? Basically a right triangle. And then you have a flagpole, so I guess I'm not done drawing yet. And I'll just do one of these. these. That's my flag.
Nice.
And you said, and this is not to scale, sorry, the sun is also hitting the flagpole and creating another shadow.
Yes.
How long is that shadow, you said?
The flagpole shadow is 30 feet.
30 feet, and you are trying to find the height of the flag.
Yeah.
So what we do is we just call that H because we don't know what it is. And if you think about this again, the sun is hitting the flagpole because it's so far away at pretty much the same angle as that person. So what we have here is two similar triangles, meaning all of their lengths of these triangles should be proportional and all the angles are the same. So we can use that idea to create proportions. So the tricky part here that I've noticed an issue is thinking about like, okay, I got this length of the shadow and as a proportion to this length. So if you remember, we can set up like the shadow of the person is 6 feet to the shadow of the flagpole, which is 30 feet. And then we can set up the proportion. And the important thing here is to make sure if you're using the person's shadow, if you're using the triangle on the left first, that you also do it when you're setting up the other side of this proportion. So we have that Jacqueline is 5 feet tall. So we're going to put that up here. And the flagpole is H feet tall. So basically what we're saying, because these triangles are similar, is the proportions need to be the same. Does that make sense?
Yes.
Okay. Do you know what to do? Does this kind of like look familiar to you, this kind of equation? Or if I do this?
Familiar enough.
Yeah. So what we need to do here to solve is actually cross multiply. So we're going to multiply kind of diagonally here. And we're going to say 6h equals, and we're going to come over here and do the same thing, equals 30 times 5. Does that make sense?
Yeah.
So we have 6h equals 150. And then I'm assuming that you're comfortable solving equations.
Sure.
So we're going to divide by 6, divide by 6, and we get the height, which is 225 feet. Right, so we're able to use this information about the shadows created by Jacqueline, the shadows created by the flagpole, because they're created by the sun and the sun hitting these objects at the same angle. We have similar triangles which will be proportional. Okay. Does that help?
Yeah.
All right.
Did you want to take a guess at the trivia question while we have you on the phone?
What was it?
Do you want to take a guess at the trivia question?
Oh, no, the trivia question.
So the trivia question, and this will go to everybody, so if you don't get it, but no big deal if you don't, but if you don't get it, this is our trivia question, is what was the world's first internal combustion automobile? Do you by any chance know the answer?
I'm going to go with no. It's going to crash and burn, so.
I wouldn't know either. I totally understand. But I thought I'd let you get a stab at it anyways. Hey, thank you so much for calling. We really appreciate your questions. Feel free to call us back anytime.
Yes, thank you.
All right, take care. So you guys saw it. That's our trivia question. We still don't have a winner. So within the next 3 minutes or so, give us a call if you have a guess. There's nothing wrong with giving a guess. The phone number's on the top right of your screen. In the meantime, let's go back to Lily, try to squeeze in one more social media question.
Yeah, we're going to do a quick science one. This one asks, why does my hair stand on end when I take my hat off on a cold, dry day?
All right. This is another one of those science questions that I feel like could so easily just spiral into a ton of information, but I'm going to try to keep it simple. Okay, so when materials come into contact with each other in the physical real world, there's an opportunity for electrons in the atoms that make up those materials to essentially be scraped off. Particular kinds of atoms sort of have loosely bound electrons. They're just sort of barely holding on to those electrons. And then there are other kinds of atoms that would really like to take electrons away. And these atoms can exist in lots of different kinds of materials. And so what essentially is happening is electrons are tiny little particles that have a negative charge. And when they get exchanged, so we can imagine your hair normally is neutral, does not have a positive or negative charge, as would be the fabric in the hat. But if the hat and the hair come into contact, scrape against each other, there's an opportunity for some electrons to be scraped off and to create a charge imbalance. So you might have a positive charge in the hair. And one of the reasons that the question mentioned a cold, dry day was simply because if the atmosphere is very humid, if there's a lot of water in the air around us, then the air is more conductive. And so if you have electrons scraped off of something, it's fairly easy for them to travel through the air and away from the point where they were created. But on a cold, dry day, or on a dry day specifically, it is likely that those extra electrons that are going to be changing places, creating the charge imbalance, are going to stay local to wherever that scraping of materials happened. So that's my really quick answer. The word you're looking for is static electricity.
I like it.
Mm-hmm.
I like it. Always learning.
Oh, yes.
All right, well, we've got to get our trivia answer. So I'm dying to know the answer to this one. Lily, what is the answer to our question?
So the question, just one more time, was what was the first internal combustion automobile? And that was the Benz patent motor wagon in 1886. Looks fancy.
Wow. Oh, wow.
Can you imagine driving that down the road today?
All kinds
That
of
would be
ways.
pretty nice.
That would be pretty nice. So that was called what again? That was called the Benz
Patent motor wagon?
Mm. Well, the first vehicle was a steam-powered tricycle. Well, I mean, that pretty much looks like a steam-powered tricycle.
Just internal combustion.
It's an internal combustion powered tricycle.
Well.
That's the upgrade.
Well.
I would have thought that, I don't know, just off the top of my head, I thought Ford, but I think it's just because of the Motor T.
Right, it's
and
such
the
a classic. It is
production.
an old car, but you know,
Yeah.
I was even looking. So the Oldsmobile factory is even older than the Ford automobile factory.
But well, we were discussing earlier, I guess, why that's coming to mind. Lily, you got an answer to that. What's the answer? I can't remember. Was that
which one?
The Motor T or the Ford?
Oh, gotcha. I mean,
or the Model
or
T.
Model T.
Sorry,
I mean,
not-
I just assumed it was Model T because I'm from Michigan, so
Model
I
T.
just
Oh.
pretty much like assumed right away it would have been the Model T because growing up, everyone's parents work at the GM factory or the Ford factory, so
Yeah.
it's kind of like that's what I assumed at first, but
But
then
really,
I
it
found
was
out it
just
was actually
the assembly
yeah,
line.
it was, yeah. And so it was actually pretty crazy to find out. When we actually did find out that the car was actually German, the very first car, it was really disappointing. Because I thought that's why we were known for the Motor City, but no, it's German, but oh well.
It's just
Kudos
because you
to
guys
the
are really
Germans.
good at manufacturing.
Yeah.
Yeah,
cars.
Ford
That's
is really
all.
good at
You're
like
just good
Yeah.
at it.
streamlining that whole process and
Yeah.
getting it done quickly.
Absolutely.
Yeah, you know
Yeah.
that the assembly line synchronization that the Ford's introduced. That I was looking. So the man-hour time to make a car before the assembly line was 12.5 hours, and it got shortened to 1.5 hours.
Wow.
after
You
the
can
assembly line.
imagine how much more expensive it would be if somebody is putting 12 hours of manpower into something versus 1 hour.
Oh, insane. They said they were using way more people at the time, so they got to cut down on
Right.
people, increase profits, and that actually increased pay for all the workers who were on the line, which made, and you hear this talked about a lot, those jobs in the early car factories in the States were really good jobs to have.
Right.
And they changed it by, I think, if I'm remembering correctly, correct me if I'm wrong, that before it was like one person doing a lot of different jobs, and what they did at Ford was one person did one job, so your job was like to put a panel on a door, and
Exactly.
you just kept going over.
And the word you're looking for is specialization, so they had
Yeah.
people specialize in one particular piece.
Yeah.
All right, well, thank you guys for joining us on Homework Hotline today. We'll be back again tomorrow to answer all of your homework questions that you didn't get answered today. We'll be back from 4:30 to 5:30 p.m. And in the meantime, if you miss us just so much, check us out on Facebook, on Twitter. You can send in some questions as well if you'd like to do that in advance. But thanks again. Hope your week is going well, and we'll see you tomorrow.